Good morning, everybody. This is Mr. Spottleson. I guess it could be good morning, good afternoon. I don't really know when you're going to watch this video, but good something. Um, Today I'm filming this on Monday. It's the day after Easter. I hope that everybody was able to enjoy their Easter and was still able to connect with some of their family who they might not be able to spend Easter with. I hope that you guys were all able to enjoy that. Um, my family definitely, we were FaceTiming grandmas and FaceTiming aunts and stuff because they didn't want to risk anything breaking their quarantine. So didn't wasn't a normal Easter at the Spottleson family, but we made the best of it. So I hope you guys are able to enjoy that a little bit. Today and this week we're really gonna go into just focusing on one section a week. Okay, I don't want to. We're not going to go crazy or anything. We're going to try to keep it at a manageable load for everybody. And the other thing is, we're going to start to bounce around a little bit. Like you might see us do one section and then randomly switch to another section over there. And then we've kind of talked with the geometry teachers for next year, and they've kind of given us what they think is the most important going into their class next year. And I think the best way to do that, I think that's the best way to do the end of this year and the end of how the school's going to go. So we'll just focus on small things that they think's really important. Okay. So today is going to be section 11.6. I don't have any notes or guided notes for this one. So just kind of take notes as we go. There'll be a worksheet for homework or an assignment. There'll be a worksheet that'll be due on Friday of this week. Okay, you've got all week to complete things. So that is that. And again, this is section 11.6. It's on radical expressions, and this will be day 1. All right, section 11.6, radical expressions. All right, here's a couple notes for you. We've already known this one. An expression that contains a radical sign is a radical expression. That's the radical sign right there. There are many different types of radical expressions, but in this course, you will only study radical expressions that contain square roots. Okay. So I would write for that, I would write just the top part here. An expression that contains a radical sign is a radical expression. Okay. And then you'll hear me say this, and here's a couple examples. All right, just the square root with things underneath it. All right. And then the second definition is the expression underneath or under a radical sign is the radicand. Okay, and you'll hear me say that every once in a while just for technical terms, but the radicand, it's the expression underneath. So it's just the 2GD, or it's just the 2, or it's just the 18, or the 14, or the L2 plus W2. Okay, so it's the expression under a radical sign. That's what we call the radicand. Okay. Just a couple notes to kind of check up on and make sure we're all good with. All right, the first thing is we want to remember that 16 squared equals 4. And the reason for that is because 4 squared, or 4 times 4, equals 16. Okay. 16 is an example of a perfect square. We don't get any decimal when we do the square root of 16. Okay, the square root of a perfect square is a whole number, right? 4 was a whole number there. That's when you know it's a perfect square. Okay, we're very familiar with that. Here's just a list. I think you know. Okay, I don't think there's any we've used these in class so much. I think that we're pretty familiar with all of these. Okay, 1 square, or square root of 1, square root of 4, square root of 9, square root of 16, square root of 25, and so on. We've done a lot of. Now, these, I think it's probably important you write down. Okay, just because these are the not as common ones, some of these, and there could be some situations where you have to deal with these, and it's good to know them. Okay, so the square root of 11, that one probably a little bit more familiar with, is going to get us 121. It's going to be 121. Okay, not the square root of 11. I'm sorry. Square root of blank equals 11. It's 121. This would be the square root of 144. Okay. 13 would be square root of 169. 14 would be the square root of 196. 15 would be the square root of 225. I'm sorry, 15 would be 225. All right. Square root of 16 would be 256. Square root of 17 would be 284. Square root of 18 was 324. Square root, I keep saying the square root of and then the number. Square root of blank, so square root of 361 would equal 19. And then the square root of 400 would get us 20. Okay, these please write down. These I think are really important for you to know. I'm not going to quiz you on them, I guess, but kind of important to know. All right. All right, so we're going to be simplifying these things a little bit, and we get this. This is very important to write down. The simplest form of a radical expression. Here's things that make it a square root. Okay, the first one, an expression containing square roots is in simplest form when the radicand has no perfect square factors other than 1. Okay, if you need to pause this at any time to have time to write this down, go ahead. The radicand has no fractions. Remember, the radicand was what was underneath the square root. Okay. And there are no square roots in any denominators. Okay. And you're going to see a lot of what that means here soon. Okay. And then these are just some examples of not simplified, ones that are not simplified completely. Okay. You've got radical 8 has a perfect square factor in the underneath the in the radicand there, 8. Here's a fraction. Okay, and there's a square root in the denominator. It can't have a square root in the denominator. Okay, so I'll show you what to do when we have these situations. All right, we're going to go ahead and skip this example 1. We'll deal with that again on Wednesday. Okay, we're going to go right to example 2 here. Okay. All right, so there are 2 ways to solve these. Okay, and we are going to focus on one way today, and then on Wednesday we're going to focus on a different way, and you can kind of decide. I like this first way that we're going to do today, but some people are different. Okay, so we've got the square root of 60. Okay, so the way we're going to do this is the factor tree method. Okay, we're going to do the factor tree method, something we've done before, we're familiar with. Okay, so that's what we're going to do. All right, so remember when we do our factor tree, we take our number, we write it up top, and then we think of something that'll multiply to get us 60. Now, you can always pick 2 if it's an even number. Okay, that's always a safe bet to do it, and it'll take a little bit longer, but you'll get there. For 60, though, I can see that 6 and 10 multiplied together get me 60. And then 3 and 2 multiply to get me 6. Now, those are both prime numbers, so I know I'm done right there. And then 10 is 5 and 2, and those are both prime numbers there, so I know I'm done there. Now, when I go over here to rewrite this, okay, the first step to rewriting this is to write the whole thing out. So we've got 3 times 2 times, and another way, and I don't normally do this, but it just kind of hit me. Let's write it least to greatest. So let's write both of our 2's. So 2 times 3 times 5. Okay, and you can always check. You can go to your calculator right now, and if you plug in 2 times 2 times 3 times 5, you better get 60. Okay. I do. I get 60, so I know I'm right. And here's how we finish this up now. We want to look for pairs. Okay, and we have a pair right here of 2. And when they go, if they have a pair, if you recall, we can bring that outside. Okay, and they become 1 when they go outside. So if it's a pair of 2s, only a 2 would make it outside, and we'd have what's left inside. In this case, it's 3 times 15. And the square root of 60 simplified would be 2 square root of 15. Okay? So, right there, that's our first way to do this using our factor tree method. Okay? Moving on. We've got the square root of 72. So same thing here. I'm going to go and I'm going to write my factor tree. Okay. Then we're going to think of things that multiply to get us 72. In this case, I'm going to roll with 9 and 8. Okay. Oh, I can't see my thing right now. 9 and 8. And then from there, I got to keep going because these aren't prime numbers. So I'll go 3 and 3. That's definitely both prime, so that's over with. And then 4 and 2, those are both prime. So when I come back over here now, I'm going to write this all the way out. Least to greatest again, so 2 times 3 times 3 times 4. I've got 1 pair, which is 3 and 3. So when they come outside, they're going to become 1. So it's going to become just 3. And then 2 times 4. Then if I simplify that one more time, I'm going to have 3 square root of 8. Now, another way you can check this that I've always done is you can go ahead and plug in square root of 72 in your calculator. You're going to get 8.482528137.4. Okay, and you can just kind of remember the first couple decimals, that 485. Then if you go back to your calculator and type in 3 square root of 8, you should get the same decimal if you did it correctly. All right. So we get 3 square root of 8. All right. Square root of 675. We're going to go with our same thing here. We create our factor tree. All right, what multiplies to getting 675? I'm going to roll with 25, and that's going to be 27. Yeah. So 25 and 27. And then 25 will be 5 and 5, and that's both prime there. And then 27 here is going to be 9 and 3. That's prime. And then we'll do this one more time, and we get 3 and 3. All right. Then once I've got all my prime numbers here, and I can underline them all, I'll come back over here. So the square root of 675 equals, again, I'm going to write it greatest to least. So 3 times 3 times 3 times 5 times 5. I've got a pair of 3s right here, and I've got a pair of 5s right here. So that can both come out. But remember, when I bring them out as pairs, they become 1. So on the outside, I'm going to have 3 times 5. And then all I have left on the inside is that 3 right there. And then I'll simplify this to 3 times 5 is 15. So 15 square root of 3. Okay, and again, you can multiply 15 radical 3 in your calculator and do square root of 675, and you should, if you did it correctly, get the same decimal. Okay, let's look at one more here. Now, this one here is a little bit different because we've already got something on the outside. Oh, but it really doesn't change much for us, okay? We're going to first start out by just focusing on the number that's on the inside. Okay, we'll touch up with the number that's on the outside here in a second. Okay, so in this case here, 96. Let's just do 2 and 48. Okay, so we do 2 and 48, and then 48 we do 6 and 8. Okay, 6 would be 3 and 2. Those are both prime. 8 would be 4 and 2. That's prime, and then 2 and 2. All right, so we've got 1, 2, 3, 4, 5. Oh, that didn't. Yeah, okay. So we come back over here now, and we're going to keep our 3. That's very important to keep your 3 right there. And then we're going to write everything else. So we have to do a 2 times 2 times 2 times 2. So let's do boom, boom, boom. So we've got that one, and that one. And then we've got times 2 times 3. Okay. And like anything else, we want to check for our pairs. So I've got a pair of 2s right here. I got a pair of 2s right here. So these are both going to go outside. Okay. Now when they come outside, they become 1. So on the outside, I'm going to have a 3 times 2. Now, since there's 2 pairs, I'm going to have another 2. And then left on the inside would just be what's not a pair here. So 2 times 3. And we'll simplify that by doing 3 times 2, which is 6, times 2, which is 12. And 2 times 3 is 6. 12 radical 6. Okay, you see, I just kind of included the 3. Okay, the 3 was already out there. I just kind of included it in the multiplication problem with the 2 pairs that I brought outside. Okay? All right, let's continue moving on now. Okay? Now we're going to add, don't want that yet. Okay? Radicans with variables can also be simplified. Okay, and I'm not going to go through every single one of these here, but go through a couple here. If I have x squared, okay, that's like x times x. All right, I've got one pair, which is x times x. So I'm only going to have something outside, and it's just going to be x. Yes, you can see that radical in the square root sign there should cancel out and just be left with x. That works too. Okay. Here we've got x to the third, so that's like x times x times x. We've got one pair right here. So in this case, we'll take one pair out and we'll have x radical x. Square root of 4, we'll have x times x times x times x. And we've got a pair here and a pair here, which means that we're just going to take those 2 out and have x times x on the outside, which equals x squared. And we'll do one more here. Like I said, I'm not going to go through all of these. I'm going to do that last one. X to the 5th, we'd have x times x times x times x times x. I've got a pair there and a pair there. So I'll take both of those out. So I'll have, we'll take an x times an x outside and have an x left inside. And the square root of x to the 5th power is going to be x times x, which is just x squared. And then inside would still be that leftover x. Okay. All right. And then if we go down here, again, this one, if you write only this one down, I'll be happy about it. Okay. This one here, all right, if I write this out, I have a big long radical sign here, and I'm going to have x times x times x times x times y 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 times y. I think that was 8. 1, 2, 3, 4, 5, 6, 7, 8 times what is going on? Times z times z times z. All right. And then we'll go ahead and find our pairs. So I got a pair here, a pair here, a pair there, a pair here, a pair here, a pair here, and pair here. So on the outside, remember when these come outside, they become 1. So I'm going to have an x times x times y times y times y times y times z. And then on the inside's 1z. So then we can do a lot of simplifying here. I messed up. No, I didn't mess up. Okay, and then when I go ahead and set this equal to here, I'm going to have x squared y to the 4th z square root of z. Okay, again, all I did was brought out my pairs. All right, so let's take a look at this and we'll finish up with this for today. Okay, simplify. All variables represent non-negative numbers. Okay. The first thing I want you to do is only focus on the number. Okay, so 50. So I come over here to 50 and I say, well, 50 is going to be 5 and 10. That's prime, and then 5 and 2. Those are both prime. Okay. Now, when I come over here to write it out, what I want to do is I want you to start with the numbers least to greatest. So 2 times 5 times 5. Then go ahead and write out everything here. So x times y times y times y. And again, there's 3 y's there because the exponent's 3. Now I can circle all my pairs. So I have 5, I have an x, and I have 2 y's. All of that's going to go outside and become 1. So I'll have 5 times x times y. And then I'll have my radical sign. And then what's left? So 2 times y. And when I simplify that, I'll have 5xy times the radical 2y. Okay. Again, whatever's left underneath the radical is just the numbers that didn't have pairs. Okay, 2 more. All right, same thing here. We've got 160. So let's start with that. All right. So we've got 160. How can we multiply to get that? We can go with 20. And what would that be? 20 and 8? Yep, 20 and 8. And then we'll do 5 and 4 for 20, and 2 and 2. And then we'll do 4 and 2, and 2 and 2. Okay, prime, 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 prime. Okay, from here now, we're going to write this whole thing out. Okay, if you want to pause the video and write this on your own, see, make sure you know how to do it. That's fine. But we're going to go least to greatest. So 2 times 2 times 2 times 2 times 2 times 5. And then we'll write out all of this. So times A times A times A times A times B times B. Cool. We've got it all written out. We can identify our pairs. So I'm going to have a pair of 2's, a pair of 2's, a pair of A's, a pair of A's. All of that's going to leave the radical sign and go to the out front. Remember, though, when it leaves the radical sign, it becomes 1. So I'm going to have a pair of 2's times a pair of 2's times a pair of A's times a pair of A's. Oh, I did have a pair of B's, too, that I forgot. So times B. And then inside the radicals, which is whatever's left, which is 2 times 5. Okay, so on the outside, I'm going to do all of this. Okay, so 2 times 2 is 4. And then A times A is A squared. And then there's just the B that'll go out front. And then square root of 10. So my answer is 4A squared B times radical 10, or radical 10 there. Okay. All righty, last one for today. Okay, we've got 504. Okay, so we've got 5 radical or square root of 504 x squared. All right. First thing we're going to do is factor out our 504. So we write our 504 over here. And then we've got to find something here. Remember, you can always go 2. Can't identify anything. I'm going to try to make it a little shorter and go 4 and 126. Okay, 4, that'd be just 2 and 2. And then 126 here would be 63. So we'll go 63 and, oh no, I messed something up here. I did a double here. 126 will be 63 and 2. And then 63 would be 9 and 7. That's prime. And then we'll have 3 and 3. Okay, so we've multiplied all of that out there. And then we've got all primes, right? 2 and 2, 3 and 3, 7 and 2. Okay, all our n's are primes. So we're going to first start by writing that all out. A key part of this is to make sure you don't forget to include this 5 still. So this is still going to equal 5. And then square root. And then we'll write least to greatest like we've been doing. So 2 times 2 times 2. So we've accounted for those 3 there. Times 3 times 3. Times 7. Okay, and then we'll include times x times y. Okay, we identify our pairs in here. We're going to have a pair of 2s, a pair of 3s, and a pair of x's. Those will all leave, okay, and join the 5, and they'll become 1. So in this case here, we'll have our 5 still, times my pair of 2s, so times 2, times my pair of 3s, times my x. And then my radical sign will have my non-pairs. So 2, 7, and y. So 2 times 7 times y. We can multiply all this out. 5 times 2 is 10. 10 times 3 is 30. So this will become 30x on the outside. And then 2 times 7 is 14y on the inside. Okay? That is how we simplify radical expressions using our factor tree method. Okay? Again, this was lesson 1. We're going to focus on a different way to do this on Wednesday. The video should come out a little bit shorter because we already know all the background knowledge. There's a 9-question worksheet that I'd like you to do. And again, the due date on that will be Friday. So you have till Friday. And again, we'll just stick with the same method. If you can print it out, great. Print it out and then take a picture. If you can't print it out, then it's totally fine to use a piece of notebook paper, take the picture, and send it to me that way. If you're watching this video, I hope having your quizzes graded by the end of Monday. That's the goal. It's going to take a lot longer with online, but you know what? We are going to figure it out and do it. Okay? So I'll get those to you as soon as possible. Thank you. I'll see you again next time.